For number 5, the first part says find the vertex and state it as an ordered pair. Well, your vertex, we'll mark this as part A. Your vertex is x equals negative b over 2a. This is your A, B, C. You don't need the C for this, but I just put it there on principle. So that's going to be equal to negative 13, negative 13, so that means positive 13 over 2 times A. A is 2, so 2 times 2 is 4. So this is your x value. And when it says write it as an ordered pair, it wants it like this with whatever your y is. Because your vertex isn't just the x value. Your vertex is both your x and your y, because it needs to know where on the plane you're looking at your vertex. So, but this is vertex formula because it helps you find it. So now we know what the x is at the vertex. Now we can plug that back in to find the other part of the ordered pair. So wherever your x's are, you're going to be plugging this 13 over 4 in there. Excuse me. Let's see. Sorry, I didn't unpause it. So when I put this in the calculator, I got negative 45.125. And I think that's just an 8. Yeah. So, let's see, 13 divided by 4. So this would be that minus 45125 here. So we can rewrite this as 3.25, because that's what 13/4 is, comma, 45.125. Because you'll want to either put it in all decimal or all fraction. That's kind of the idea. You're supposed to do that. It's just what you're supposed to do. Okay, so now we got that part done. B, find the x and y intercepts. Okay, so finding the x-intercept. That's when y equals 0. So looking at this function, you're going to do 2x squared minus 13x minus 24, and you're going to set that equal to 0. Factor it, and that's how you're going to find your x-intercepts. To find your y-intercepts, that's the easy one, because that's where your x equals 0. So you can plug 0 squared minus 13 times 0 minus 24. And that gets rid of that, gets rid of that, so you're left with negative 24. And that's your y-intercept. So an easy way to remember that is your x-intercept is when you're plugging in 0 for the other one. Y-intercept is when we're plugging in 0 for the other one. And like I said, the y-intercept's always the easier one to find, but that's life. Okay, so for C, your domain is everything that your y can be. So hold on, let's plug this in the calculator and see what we get. Graphing it is a great way to see your domain. Okay, with the standard window, this is what I see. Let's see if we can see it. Oh, actually, set it down works. Alright, so the standard window is from here to negative 10, which makes sense because when your y value is 0, you're going to have 2 points usually, especially when it's squared. You're going to have 2 points. That's the 2 points you should get with your x-intercept. Your y-intercept when x is 0 is negative 24. So you're going to be going all the way down to negative 24. That's one way to be able to tell how to set your window. When your y-intercept is negative 24, you're going to be going further. So you can hit window, and your y minimum, negative 24 is what we came up with for the y-intercept. So let's go for a y minimum. Let's put that as negative 25, so just so we can see what's going on here. Okay, so that shows us our vertex, which we found up here to be negative 45, is going to be down here somewhere. And the line is crossing over here. So if we want to see the whole graph, we could put this down to, let's do negative, since our biggest y is going to be negative 45, let's do negative 46. We don't need a double negative. Now see how you can see your whole graph? That's kind of the whole purpose behind finding the vertex, which is that point right there. There's your x-intercepts, and there's your y-intercept. Okay, so let's see. I think your equation for axis of symmetry is your vertex. I'm pretty sure that's what it is, because your axis that it's symmetrical should be the x. Because if you were to draw a line straight down the middle, you're going to find it at 3.25, and that looks about right. So it should be right down the middle. Let me see if I got something pointy. Here we go. Something like that. So see where this thing is crossing it? It's like if you were to fold it like a sandwich. This x equals 13/4, or 3.25, is where you're going to find that axis of symmetry. If this thing were to be flipped this way, your axis of symmetry is going to have this way, but you won't see any of those for a while, I don't think. Solve for f of 3. You're just going to plug in a 3 there, and 3 everywhere you see an x. Okay, let's look at this last one though. F of x equals negative 9. That's where you're going to say 2x squared minus 13x minus 24 equals negative 9. You can add your 9. I don't know. Let's see. Go away. Oop, wrong button. Okay. Negative 24 plus 9. Now from there you'd be factoring, which that you can use the AC method, because 2 times 15, oh wait, maybe not, I'm not sure off the top of my head, but that one you're just going to factor and solve for x, because the problem says solve for x when that. So alright, let's see, next problem. I'm going to finish making this in like one long video, because for some reason my YouTube's not wanting me to upload a bunch of videos. It's being stupid. John wants to enclose his goats in a pen. Okay, I'll pause it. Hold on. Okay, so factoring completely. This is where you either use your AC method, you can kind of eyeball it, or you're going to use that quadratic equation. So for this one, it's got a, let's see, we got 2 x's. Something's going to be a minus, because something times something's got to equal 18 and add up to negative 3. So we got 3, 6, 9, 12, 15, 16, 17, 18. So 3 and 6 multiply to 18. And to get negative 3, you're going to need a negative 6. So that's kind of the way to think about ones like that. This one I would try AC method. If it doesn't work, you're going to have to go back to that quadratic equation. I don't have it written down here, but same idea, same idea. You're probably going to have to go back to the quadratic equation for a lot of these. Let's see, 15 times 4, 60, up to 17, divided by 2. No. Oh wait, hold on. 60. No. Yeah, I would, like I said, try with your AC on this one. And if not, go back to your quadratic equation. These ones, you're going to have to factor them individually. So let's go to this one. Let's look at this as x plus 3, x minus 6 is less than or equal to 0. And graphing it is always a really good idea. Oh, you'll want to reset your window though. So we're specifically looking at where your x's are less than 0. So it's that one that we're looking for. So we've got x plus 3 is less than or equal to 0. X is less than or equal to negative 3. Yeah, so we're specifically looking for where in this equation it's less than 0. I'm pretty sure that's what we're doing on this one, but I'm not 100% sure. So you may want to check your notes on this. Oh, there's an interval. Okay, so it should be, like I said, I'm not sure about that one. Give me a second on that one. I'll come back to it. The height. So that kind of tells you, for one thing, the height of that the ball is released. So when you're throwing a basketball, and the height that the ball is released, that means when it's released, you're letting go. That's when time is 0. So you can plug in 0 for your equation and get that the height, which is your y, is going to be 1.9. The maximum height the ball reaches. The equation probably looks something like that. You're going to look at this top point, and that would be your vertex. However, since it says height, that means it's looking for the y value. So you're going to find your vertex and then plug it in into the function right there. So you're going to say x is equal to negative b over 2a. Whatever you get there, you're going to plug back into your equation, so that way you can find your height. And you could do that pretty easily on the calculator, because if you plug in, let me make sure we can see what we're doing here. And of course we can't. Sorry, the lighting's weird. Okay. Negative 7.3. We'll put an x squared because that's how the calculator likes it. Okay. So, damn it, the thing's still weird. Okay, so we can go window. Now we'll do zoom, and we'll do a standard. Okay. I don't like this because it's so cramped, I can't really point to it. So I'm going to fix the window. Since we're not really worried about anything past, like this way, I'm going to put my minimum x value as 0. That way it will kind of spread it out a little bit. Okay. You know what? I'm going to cut it again, because this is 1, 2, 3, 4. We'll put it at 4 for an x maximum. Okay, look at that nice arch. Okay, see, this is where we started throwing it. This is your maximum value. That's where your x is going to be negative b over 2a, or you could do this. Second, calculate, and go up to the maximum. Left bound is going to be left of this point here. So it's going to be left of this point right here. So we'll just go there. And then we go around to the other side of it, right bound, right of that point. Guess that is the x value you would get. That is your y value. That is the height that it's asking for in the question. Let's see. Little action figures are getting wrong. So, okay. So when it says maximum height the ball reaches, it's actually talking about this point up here, which is your y value. So it wants the 5.675. Let's see. Yes. Zoom, please. There we go. Okay, now you can see the values. Okay. Oh, shoot. Hold on. Okay, there we go. Now, if the goal is 3 meters high, when will the ball reach the basket? Okay. So since we're talking about high, that's height. So that's going to be, when does this equation equal 3? So you can say negative 7.3 t squared plus 10.5 t plus 1.9 equals 3. That's an equals. Sorry. So now you subtract your 3. And that's going to give you something. It'll be negative 7.3 t squared plus 10.5 t. And that'd be minus, let's see, 1.9 minus 3 is negative 1.1. Okay. Yep. And that's kind of what you're looking at for there. So let's see what happens when we put that in the calculator. When that equation, let's see, hold on a sec, I don't think that's how we wanted to do that. Let's go back to the original equation. I'm not sure, let me come back to that one.